All right, in this video, I'll show you how to make this wheel stud and this custom nut, and then I'm going to give you a challenge to do these over here. So this is a M12 metric 12 millimeter, 1.5 millimeter pitch nut, or actually a bolt that is 60 millimeters long. That's the image right over here. Let's see if we get another picture on Amazon. We just want a picture that we can pull into Autodesk Inventor so that we can get a sketch of it. So let's click on this right here. And then go in there and use your print screen again, as we normally do. I think I have something down here called Light Shot, right? And you can just use a snipping tool. And then copy this right here. And yeah, let's just save that to the desktop or wherever you would prefer. Loading up Inventor. We want to make this one a metric piece. So new. Oh yeah, and you probably want to change. Yeah, let's change this over here to nuts and bolts. So project, new. Oop, wrong way. There we go. So we're going to start with the bolt first, and then we'll do a nut at the end. And here we go. So file new, metric, and we'll start with the millimeter. Now let's go ahead and insert that picture perhaps, but we want it on a sketch of some kind. I want to make this on the XY plane, and then we move this down here. Let's see, where is our image insert at? Right here. Go to our desktop, and there's a screenshot. And we can place it in like this. And I didn't really anticipate that. Really kind of wanted it horizontal. So what I'm going to do is try to rotate this. I haven't really played around with this very much in these videos, so I'm going to show you how to do that. Go to the rotate tool on Sketch, select a point, and then I think you select, oh wait, the center point here. Oh wait, let's see, there we go. Then you can rotate it around like so. But we prefer to kind of move it over toward the origin a little bit, but that's okay. Now what we want to do is try to get the best estimate for dimension that we can of the 60. Now the 60 is the length of the shaft, not the head up here. So we're going to go like this for 1.1 over here as well. And then as we normally do, set the distance between those 2 points if we can find them. Where's the other one? Oh yeah, right here. All right, we want that to be 60. So that's actually smaller than we're looking at. And the reason I wanted to do that is because I kind of wanted to come up with a way of estimating the rise here and the length of the no threads there. So let's get started on, let's see, maybe just draw a line down the middle, connecting those 2 points like this, if we can find them again. And then what we're going to do is draw an outline of that shape going up, then over, and then we're going to stop right about here a little bit because it looks like it goes in just a bit, not very much. Then we go out to this distance, then come back over here. So that's kind of roughly what it looks like. It does look like a smaller diameter here than on the threads. Okay, so I think at this point we can hide our image so that we can see, we get something that we can rotate or revolve around. Now, you can just barely see those differences there. I wonder if that's enough. So let's do a couple of things. Let's put ourselves at the origin right there. And then let's start connecting things together again. So right here and down there. And then also this one needs to be vertical with the origin, so I didn't quite make that. And so you can see that you can click that point and the origin and it should line it up. Still kind of missed the mark on that one. Let's see if we can do a couple of things here. One of them is at this dimension right here. I think it should be 6 millimeters, but let me double check that. Didn't it say when we looked at the assignment that it was going to be an M12 bolt right here? Yeah, metric 12. That's the diameter of the main shaft that we're going to use. So let's do something a little bit different. Let's change this line right here to a center line. And that's going to be located right here. Because what we're going to do is use the revolve tool. We'll delete this right here. And we're going to measure the distance from here to here all the way. Is it going to let me do that? Usually it comes down this way. That's the center line. Usually when you click this dimension and then click here, then click there. Okay, there it goes. That worked. Then click here, here. It didn't work for that for some reason. Okay, I wonder what I'm doing incorrectly here. So I'm just going to delete a couple of things we may not need anymore, like that point at the end. Doesn't want to delete that very easily. Okay, so I guess remove that constraint. Highlight that, delete it. Does not want to let me delete that. Let's see if I can move it down, maybe, but still, I need to be able to revolve it around here. Okay, it's being difficult. So instead, let's redraw the line and see if I can revolve it now. And still a problem. Okay, so there's something I'm not doing properly. Perhaps we need to close off the shape here. So let's go down here like that and see if I can measure this one. Nope. Okay. I was going to try to do it that way with the revolve, but it doesn't look like it's operating well for me. So instead of that, I'm just going to say take the distance divided by 2. So it's going to be 6 millimeters, and then that's going to give me 12. So then this one was just a little bit inside of that. So we can go from here to here and just make it a little bit less than that. Let's see what 5.75 looks like. That looks pretty good. Then we can connect up our lines like this. Doesn't want to do that. And then on this one, I think we're just gonna have to eyeball this one, maybe with having the image back in place. All right, so let's see why this one doesn't want to meet up there. Oh, right, because I have to have a step in there. I don't have that. So I'll go here, go up, and then over. And I should have made this one right here vertical. Oh, I did. All right. Now somehow this line went down. Oh, that must be for the image. Okay. I was really trying to get it to line up here. Let's see if we can make the bottom of the image right here collinear with this one so that these distances start to work. I think that's what was happening. And so for this one, now that I've kind of messed it all up, I really think we're just going to have to estimate this. The main thing is we want this one to be 12 diameter on this one. So that's why we're doing 6, because the threads are really what matters a lot in this case. And to have a little bit of relief here, this knurled part, or the one that has the lines running down it, going over here to visibility in our sketch. You can see these lines right here. I'm going to challenge you to put those in there. I'll even challenge you to put like a little taper in there, or like a chamfer at that point if you want to as well. Okay, so we're just going to estimate how that's going to look, then also estimate the size of this head right here. Okay, let's see if we can come up with something good. For those, we'll snap back to this picture in just a moment. So I had that one. And I think I might have it in a pretty good shape right there, actually. And going up here to approximate the head of this bolt, we have that. let's see. Yeah, we're actually going to just close it off here at the top. Let's see what that looks like revolved around before we start butchering it. So go over here to the revolve tool, and we need to pick our profile. And I guess I didn't really close this properly now that I look at it. So it's going to delete that. Oh, that one was projected, so that's okay. Let's try to close that shape in our sketch all the way from beginning to end. Then we'll try to revolve it. I just really like it when you can turn this into this, because if you do it the right way, you hit revolve and it knows exactly what you're doing, just like that. Okay, so this is going to be what we're going to do then. We'll just leave it just like that. You saw the process that I went through to pull that off. All right, let's put some threads on here. Let's put like a little chamfer on here and on here. Let's see what a 2 mm chamfer looks like right there. Huh. So maybe in one. Yeah. And here. Didn't really mean to put one right there. So cancel and chamfer just right here and right there. Sometimes you'll put a fillet up in here to add strength to the part. 1 mm ought to do it. That way it's less likely to shear at that point. Time for some threads. And so the way we need to do threads on this one is to look at the cross section. So we're going to say view, we're going to say half section view right here. So you have to do the drop down list, go down to the origin, and then start slicing until you get a good slice like that one. Hit OK, and then well, make that visible. And now it's time to make a sketch on the surface for the threads. So the way you do the threads is you start down here at the end, and you project this surface onto a sketch. So we should already be on a sketch. No, it doesn't look like it. So let's right click on the face that we're working on right here, new sketch, and going back over here to where we need to cut. So we have to have it to behave like a lathe. So we need some kind of triangle to cut into it. Let's see. So let's do sketch and we'll project this geometry. Somehow I'm not in the sketch again. I'm not sure how that keeps happening. Right click, new sketch. I'm just going to zoom out and then pan. Okay, maybe that's better. Now I can project geometry up this line because I want my cut to happen right there along this edge. And what I mean by cut is I want a triangle to cut into that surface to make my threads. And these two need to be equal to each other here for symmetry. So isosceles triangle. These two need to be an angle of 60 degrees for a standard thread. And the pitch of this thread, as we saw in the instructions, was 1.5 millimeters. That's the specification provided by the manufacturer. Okay, the next thing I want to do is maybe move this out so we can get a good look at it. So escape, get it back over here to the cutting area. And we do want it in line with that. So we will put a line here over to there and make that a construction line and give it an arbitrary distance of like 2 millimeters. Now, let's see if we can go ahead and cut those threads. And so the way we do that is 3D model, coil. We select this profile right here. It's already selected. Now it's saying select axis. Look down here at the triad, which means underlined blue right here means we need to select the X axis. It's going the wrong direction, so we switch directions. We also tell it that we want the pitch to be 1.5 millimeters. And what we could do is tell it how many revolutions we want it to go down this whole list. But maybe a better thing to do would be maybe doing the pitch and the height. So instead of going 10 millimeters, I wonder if we can just drag that. I don't think it's going to let us do that though. We could go in here and measure that distance or just type in 40 to see what happens. We want to basically get it to stop approximately here. So let's try 35, and then we'll try 32, and then we'll try 33. And that looks like it's going to be about right. All right, and then we say cut, and it didn't do it. Because I think it's, oh yeah, adding material instead of subtracting it. So you go back here to the coil, and you say edit the feature and tell it you want to cut instead of extrude. And so there's your threads. You go back up to view, and you go down here to half section view, and you go back to delete section view. So you can see the whole thing again. All right, so the rest of this here is we want to make this stainless steel part. So right click on this. We should probably save this as a good file name to represent the part. Let's listen to a little music. Let's see, we could call it OEM that part, but why not just wheel stud instead? Because that's really what it does. It goes and holds the wheel on the Baja vehicle. So wheel stud is good. That's me 3D printing. Keep going to the wrong window. So file, save as, and we're going to save this in our directory of nuts and bolts as a wheel stud. Right click on the material. Let's make it stainless steel or maybe some chromoly stuff if we like that. I don't know if I've seen chromoly down there before. No, maybe something shiny like just stainless steel. Okay, looking pretty good. And then your challenge is to put the knurl on there, these little stripes. And all you got to do is cut a V this way and then this way rather, and then rotate it around this, do a rotating pattern around. And to do another challenge, I think I'll just try this one. What if I do a right click new sketch here? Because normally it doesn't stop right there. It usually just keeps on cutting through. And you don't have to do this part, but I like coming in here and just knocking out the rest of this, like pushing it right on through to be more realistic. So our profile is going to be that shape right there. Oh, I didn't close it. So close. So are we editing the sketch still? Okay. And then what you want to do is project geometry on the sketch. You want that little piece right there. Extrude cut. And just see how it looks now. It looks more realistic, like what you would find on an actual bolt. It wouldn't just abruptly stop there. It would let you go all the way to this smoother area. All right, so save that right there. Put your knurl on there. And let's get over here to the last part. I'll let you make this lug nut. I'll just show it to you. So after you make the nut, then I want you to make a nut that looks like this. So I'll make the easier version, and then you can expand it to be this version here. And basically, you'll just take the threads, and then you'll expand it to these shapes that you see here. Basically, a cylinder, a chamfer, and a hexagon. So it's not that terrible or difficult of a problem. This custom nut done right here. Let's see what this is. Yeah, pretty straightforward. Same kind of thing, except this has a flange down here and it does not have your knurl. So you can probably modify what you have on this one to make it look a lot like this. Just make sure you follow the specifications of having, see if I can get this thing to hide. It's going to be M10 instead of M12. So that just means that you're going to use a 10 millimeter diameter shaft, and then everything else is listed here. The pitch is 1.5, and the length of this is 60, just like it was right up there. So that's one of the things I'm supposed to do also here is to demonstrate how to read part files, and this is how you would do that. And speaking of which, let's get down here to the matching part of this, and this is the custom nut, so we'll just look at that. I don't know what the 8 ZTB means right there, or how thick it is, so let's just see if we can learn anything by looking at a part. You see, it looks like it looks like it's a normal nut, but it also has a flange on there. Okay, so we know it's M10. So we're going to approximate the outside there. Or what we can do is go over and say to Google, what is the size of the hexagon of a standard, engineering standard here, M10 bolt? That would be a good place to start our sketches with a hexagon of this size, 17. And that's what I always seem to end up doing anyway on this. So go File, New, make sure it's a metric part, create a hexagon, 17 flat to flat. Hexagon is located under the rectangle tool. '17. Usually this is set up so that it accidentally rotates when you grab that. So let's align, is this the right one? Let's align this one with the origin so that you get fully constrained there. Then it's time for the circle. We know it's an M10 bolt, so 10 millimeters, like that. And then I think when we extrude it, typical extrusion, if we looked this up and Googled it, would be 8 millimeters. I just happened to do this one the other day. So I happen to remember this one. There we are. Now let's just give it a little bit of style and character and also a flange. So let's see, style, character, and a flange. So that one, it doesn't really tell us what the size of this is. This is a custom nut, probably made by Polaris, maybe even not any drawings of this anywhere. But what I can do is pause the video, go over behind me, pull up this nut off the table, and measure it with a pair of calipers. So I'm going to pause the video and do that right now. Right. And I'm back. So we will go to the bottom face, I suppose, and start a new sketch there. And this is where we're going to put in that distance I just measured, up 21.3 millimeters. And we know the thickness of it was about 3. So we'll go to 3D model, extrude. This shape right here, we want to keep going down with it like that, but only 3, like this. That actually looks a bit too much also. But that's what I measured, so we'll go with that. But what we got to do on this one is we got to come back here to the sketch, edit that right here, edit the sketch, because we need to have this circle also is included as part of our extrusion. Um, so go back to the sketch, project the geometry of that circle out here. Then you click OK, and you can modify your extrusion so that it excludes that central portion. Edit feature. You go up here and say delete the profiles, select the donut. There we are. Now it seemed like they had some smooth edges to it, so we're going to do a little bit of smoothing. Let's just do a little bit of, let's say, fillets. And I want to say that it's just a really small amount, like 0.5, right there and right there. And that's probably good enough, unless you want to kind of put those. Yeah, let's just make it smooth and classy here. I don't really know what that green color is. I'm not sure if it's a paint they put on there or a particular kind of metal processing they did. Okay, so we got that. Let's click OK. Let's also, oh, I didn't like some of those in there because of the bends. That's all right. We also want to put some chamfers on these so that it'll make it easier for the bolt to go into this nut. So make it 1 millimeter and 1 millimeter on each end. This makes it easier for it to work its way in. You can go ahead and save this one. And I think, do we just call it custom something or another? It's custom, yeah, custom nut. That's what we'll call it. If we had a big collection of these, we would obviously use the OEM number, which would be the, what did we determine that was? Original OEM, original equipment manufacturer. Yeah, I kind of want to put in the OEM number, but let's just call it this one because that's the only kind of unique about this thing that's unique about this one. There is something we can also do to the top of this to make it look more realistic. And so what we're going to do here is put a circle on the top of this that happens to be tangent to this one. So basically a 17 millimeter circle that goes out to there. And we're going to put like a little flare on the end of it to kind of lower these corners because those don't normally stick out like that. And so the process we want to use here is we want to go over here to 3D model, click on extrude. We want to go down, but we don't really want to extrude. I think we want to do an intersection. And I want you to do a taper of 45 degrees. And then the other thing is you want to go on this one right here where it says to next. Okay, and then you'll see the effects of it is to give it a more realistic manufactured approach. I'll show the excuse me features again. Right here, you see that I went up to next. I went through the part. I'm using intersection and a 45-degree taper to kind of just gently shave that part off, but keep everything else. So a little 45-degree taper as we see it from the side. And why not select some material here and see if when we cut the threads, if it kind of also reveals the shininess of this. We'll make it stainless steel also. A little bit more shiny. One of the things that you see in this one, which you will not be responsible for, is if you look really close in here, it's got this green plastic right here. This is Teflon, so it's actually something that's when the threads go into there, they kind of slow down. And so um, and so the threads will go into this and they're, just fine. But once they reach this, it kind of acts like molasses almost. And so it makes it less likely that the bolt will just wiggle off. And so that is a little piece in there that's intended to keep the bolt from wiggling off. Okay, if you want to put that one in there, you can do that. You can even see it's got a ridge here. I'm okay if you make it as far as we're doing it right here. I'm always trying to challenge you a little bit. Now let's get into making the threads. Half section view. Go through our origin progression. That looks good. Green check mark. Right click on the same plane. Oh, that's not it. This one. And start a new sketch. And this is where we make the triangle. What you could do to make it feel perhaps more natural is to rotate it like this and start drawing. So do we have a sketch started? Yes. Let's project the geometry of this line out. And then we'll say, we're about to start cutting along this thing here. I think I made a mistake somewhere, and I'll show you where that is in a little bit. But let's keep going. Let's make a triangle cut. I purposely made it wrong so that I can make it right. So these two need to be equal, isosceles. This and this need to be at 60 degrees, engineering standard. This needs to be horizontal. But then which one is horizontal? See? Sometimes it's this one, sometimes it's that one. And then this one right here should also be horizontal. And we normally just give it a distance of 2 millimeter, almost like a running start. You're going to get the tool in there really close. That's kind of representing the tip of the tool before you start cutting it all the way through. Now we can cut all the way through out here without it affecting anything because cutting into air is not a problem. As we do a coil, the profile is already selected in blue. The axis is actually not this one, but the one that goes through the middle, which is the y-axis. So make sure when you click this, it underlines in blue. Yeah, there. Okay, and do we have the right pitch? Yeah. Are we overkill on the height? Sure, that's fine. Then we click OK. All right, and we're about to figure out what I did wrong accidentally. So did we get rid of the section view? Looks like I had to zoom in and out. If I go back to the original extrusion and hit edit right here. Oh yeah. Okay, let me show you there's something wrong with this right here. I made this 10. Yeah, but this other one's a 12, so I don't think that's going to help us understand the problem. Um, you know what? I'm going to open it back up. And where did I put that one? So we made a new directory in documents, inventor, and then nuts and bolts, and we did the wheel stud. Now what I can do is save this as, and you don't need to do this part. I'm trying to show you what I got wrong and how we're going to fix it. The first one we did was an M12, but now I want to do an M10. So I want to modify it to be M10. And all I really got to do for that is go back to my original profile, hit edit, and then this one right here, just make it 5 instead. It's even going to fix all the threads. You see it's a little bit smaller like that, but this is probably too big. But that's okay. Let's hit save because I want to show you what it looks like when we try to assemble this thing. And so we're going to make an assembly like that, create, and we're going to place in the 10 millimeter bolt, right click, grounded, and then hit escape. I'm going to place in the custom nut, which is also M10 now. It needs to be rotated around, let's see, the Z-axis, right? Now it probably needs to be rotated around again, maybe the Y-axis. No, Z-axis again, Z-axis again. Yeah, that way it's like this. Okay. So now I can make them co-linear by giving them a constraint along. See if I can find the shaft link there and the shaft line here, the central axis. There it was. Okay. So now we got them clicked on top of each other, hit apply, and go like this. I'll move this out here. Now, what is it that I'm trying to show you? If we go down here to view, we go to half section view again, and we slice this piece, we're going to see some issues here. Okay, so I hit the green check mark. Then I'm going to face switch direction, this one. So let's see, just say top. Look at that. That gap is way too big, right? So these threads are not going to lock in. That means that this one right here should not have been a 10 millimeter hole. Okay. So that what you got to do is look it up in a table normally. But let's just see if Google can let us know what it is. So let's see, what is the size of the, I think it's called the tap size. So what is the tap size for a 10 millimeter nut? And let's see, 8.5. Okay, so we're going to change that 10. See, the 10 is really just for the bolt, but the nut has to be adjusted to give some allowance to let it come in there and make a connection. But it's just not going to be happening here unless we change the custom right here. Double click on this, 8.5, and let's see if this does the trick. You can roll, whoa, that's not it, 8.5. If you roll all of those changes forward, look at that. It makes a smaller thread. Go to the assembly. Did it load? Did it get any better? It doesn't look like it's, yeah, it's not that much better. Okay, I think there's too much slop in that. Those, if you ask me, let's see if there was any other guidance on the taper here. This one says 8.8. Okay, maybe that's not really, maybe I'm asking the wrong question, this one. Because tap size is not necessarily what in Inventor needed. So what is the Inventor, Autodesk Inventor? Because a tap is a specific bit that you put on a drill to make the hole before you start tapping it, which means threading it. Hole size. Let's see if AI can search for this one. It still says 8.5, but I think that there's too much slop in there. This is just going to flop around like that. So show you what I mean here. Yes, if we go back over here. Oh, I just realized I can look at all of them at the same time. All right. So let's see if we could do this live and change it. If we go to this original sketch and change it to 8, and then click OK, and then we'll see if we watch what happens over here. No change until I hit finish. And it came in just a little bit more. So gosh, I guess the size of the hole for Inventor is not the same thing as tap size for the actual tool. And you can see that that looks a lot better. We still have some allowance in there to so that it's not metal against metal in there. If as long as that's about 0.4 millimeter, you're good. So all you have to do for this one is you can set this hole size right here to be 7.5, and we'll say that's good enough for what we're trying to do, which is reverse engineer a nut made specifically by Polaris. All right, so save that one and make your other two parts, and you'll be good to go here. Right down here. So make this lug nut based on this one, and make this custom bolt based on this one up here. All right, I'll see you in the next video.